Hi, hello, welcome to Infinity Stella. Today's lead code problem is middle of linked list. Let's understand the problem statement. Given head of single linked list, return the middle node of linked list. If there are two middle nodes, return middle node. Okay. So let's understand the problem statement on iPad screen. Okay. Consider consider the given the head and I'm considering the test case where the length of linked list is odd. Okay, so by looking at it we can tell that 3 is a middle node. How will say that? Just the length by 2 we can say that it is a 3 is a middle node. What about if the length of linked list is even? For even length we'll have two middle nodes, right? Like 3 and 4. So in problem statement it is clearly mentioned that we have to take second middle node, right? So that is what it is, the problem statement. How can we do it? Is there any approach you can think of? Well, actually I can think of two approaches. One is, see, what will I do? I'll take size variable and I will transfers whole array. Okay, then I will figure out the size is 6, right? Then I will transfers in the for loop where int equal to I equal to 0, I less than size by 2, because we have to transfer the element which is less than, which is middle element, right? So we are taking temp, so we will do temp equal to temp dot next. So it will move till here. So we have to return temp dot next. So that is what this approach is. And this approach, see, for transversing takes O of n, and for doing this also it will take O of n. So it will, the time complexity is O of 2n, right? The space complexity is O of 1, right? Is there any better approach you can think of? Yeah, actually I can think of. There is a guy called as Floyd who introduced tortoise and hare. So everyone knows about the story of hare and tortoise. So this guy actually introduces tortoise take one step, this guy tortoise take one step, and hare takes two steps. Let's do this. What exactly algorithm is? I'm taking first linked list of odd length. Okay, the tortoise stands here at the beginning, which is nothing but head of the node. So hare stands here as well. So tortoise take one step and hare take two steps, and tortoise moves one step and hare takes two steps. As hare reaches the next element is null, so that is the reason we stop the iteration and will return tortoise. Will return tortoise. So what about if linked list is even length? Let's see how we'll do it. Tortoise standing here and hare standing here and here we'll move 2 steps. Tortoise then again will move first 1 step, and here moves to second, which is on 5, and tortoise moves 1 step. Now here can't go further, right? Because the next element, the next as here have to take 2 steps, it can't go further. So we have to return the tortoise, right? So we have to return tortoise. So that is what, and the time complexity is O of n, and space complexity is O of 1. So that's it. That is the dry run of this algorithm. Let's code it on the lead code. Okay, I'm taking two pointers, which is nothing but tortoise equal to head here. Okay, as I mentioned earlier, here even length, its next element should be stopped. It shouldn't go further. For even length, here dot next shouldn't go further. Why a dot next? Because I clearly mentioned that here is standing here and it shouldn't cross the 2 steps, right? So if it crosses, it will show the out of bounds error, right? So that is the reason I'm taking a dot next. It's not equal to null, right? So I will increment tortoise by 1 step, which is tortoise equal to tortoise dot next, and here I'll increment by 2 steps, next dot next, which is nothing but the 2 steps, right? You have to return tortoise. So let's run it. Yeah, it is accepted. Let's submit it. Yeah, so that is what how Floyd's tortoise and hare algorithm works. Thank you guys. I hope